that helps as well. Taylor, I'm not sure where, I'm gonna go with 99% chance that yours will be on a computer, Taylor, not on paper. I can confirm that for you though. I think it just depends on where you go, but I think you'll be on computer. Everyone else will be doing paper. It's kind of obvious, and you guys have done lots of multiple choice exams, but a computer is going to mark this one piece of paper. If you do a poor job of filling in bubbles, like you fill in your bubble like that, a computer is not going to care enough to say, hey, somebody should kind of look at this bubble because it's kind of filled in, but it's kind of not, I'm not sure. A computer sees a bubble or no bubble, and it doesn't think, it doesn't have a brain, it just says, is that dot filled in, yes or no? Same thing goes if you are doing your test and you pick C, and then you go back and you're like, oh no, I'm pretty sure it's D, and then you like try to erase it, and then you fill in D, and then it kind of looks like this one's smudged, and then this one's filled in, and the computer sees two answers, and as soon as it sees two answers, it just automatically marks the question wrong. There will be no questions on this test that have more than one right answer. So just be careful with that as well. I would really, really hate, and you would hate, to know how to do something, get the question right, but have a computer mark it wrong. That wouldn't be really fair, and it happens. So just, obviously bubble sheets, you guys know how to fill them out, but just be careful with how you fill it out. So the test is broken down into sections. It says life sciences, so this is biology. It tells you which pages of the data booklet to use. So it tells you you're going to need some chemistry stuff in this section. You're going to need carbon cycle, phosphorus cycle, biomes, and the nitrogen cycle. So you know the pages you need to look at for this section of the test. Physical or chemical factor in an ecosystem, the influence of growth of plants. So physical or chemical, it's going to be something that's non-living. Yeah, sorry, Ava, it's a good strategy. I mean, you could do that for sure. Circle the right answers as you go through the exam. That's one thing I didn't mention. When you're writing your exam, nobody's ever going to use the exam and nobody's going to mark it. Literally, when you're finished your exam, whoever's there is going to take all your bubble sheets, and then they put all the exams in another box. The exams go back to the Ministry of Education and they just recycle them. They don't look at the actual test. So if you have a question like this, you can write all over your test booklet, and if you circle, D, abiotic factor, because you believe that's the right answer, that's fine. This booklet won't get marked. No one's ever going to see it again. And you can write all over. You can, think about, okay, if I had a pond and I have some water, and then, there's like a tree next to it, you want to draw a tree, and you want to draw all over it, that's fine. You need a brain break, you want to draw a picture, that's fine. One thing that, just getting back to your question, Ava, when I do multiple choice tests, if I'm really sure of the answer, I'll bubble it in. If I'm a little hesitant on it, I'll leave it just written on the question booklet. Like on this page, I would have circled D, and then I would maybe come back to it. You want to make sure when you're filling out your bubble sheet, though, you don't get questions out of order, because that could obviously be a huge problem if you started at number 2 and then answered them all right, but you skipped one or something. So just be careful. Obviously, you guys will be careful. I personally don't like going through a whole exam and then going back and filling out all the bubbles. I would just fill them out as I went. If I'm unsure, I would leave it blank. Lots of people will do it that way, though, Ava, where they will look at it, they'll answer all the questions on the data booklet, and then they'll go back at the end and fill in all the bubbles. And one reason I would not recommend kind of leaving the bubbles until the end is, imagine if you had a really, really strict examiner, not just for this test, but for like university or future down the road, and they insist at 3 hours, they're taking your test away from you. Now, if you've left all of your answers on your your data or your test pages, but you haven't filled out any of the bubbles and you run a little bit late, well, now you have a blank bubble sheet, and that's what they're going to take. So it's just kind of one of these things. If you're comfortable with it, you're aware of your timing, then you should be fine. But if you're starting to run late, it's better to have something on your answer sheet than to have nothing. I'm just going to, two's a tricky question, so I'll look at it. Might as well. Which of the following biomes removes the greatest amount of atmospheric carbon dioxide? Now, we didn't explicitly ever talk about this in class. I never said, this biome removes the most CO2 from the atmosphere. But through looking at the answers, you should be able to kind of use a little bit of reasoning to figure this out. So think about this. What in a biome would take carbon dioxide out of the atmosphere? So what in a biome is going to use carbon dioxide? Are people going to use carbon dioxide? Are something else? Trees, sure. And then we can go even more general. We can say plants. So we're looking for a biome with the largest amount of plants or trees. Well, that can be a bit tricky, but maybe we can figure it out from the answers we have. Does a desert have a lot of trees in it? No. All right. Tundra. No, that's permafrost. There's not a lot of trees there. Boreal forest is looking good, and permanent ice has no trees. So they ask questions like this because they want you to kind of demonstrate that you understand that a boreal forest has a bunch of plants in it and trees in it. And then a desert, tundra, and permanent ice don't have trees. Now, of course, we never said this specifically in class, but you can think about it a little bit and hopefully arrive at that answer. Which of the following is biotic, so living change? Now, use the following article to answer question number 4. So usually they'll put an article and then the question will be below it. It is kind of common sense, Anna, but you kind of get caught up in the moment on a test. You're like, I don't know, it's just going to happen. There's tons of these questions that are kind of reading comprehension type questions. They really, in my opinion, have no place on a provincial exam. They're not asking you about, your knowledge. They're seeing if you can read and synthesize information. This is probably a great question for an English exam, not necessarily a science test, but that's just the way it goes. So anyways, you read through the little story, you answer the question. This is kind of a tricky-ish question, not terribly bad. I'm not going to read through it right now, but I'm just going to kind of skip ahead, show you a little bit more of the test. Use the question to answer number 8 again, reading comprehension. I will go through the answers to this test eventually. We just don't have enough time. Again, chromatograph, talking about biomes. Number 12 was tricky as well. Lots of reading stuff on this test. It's pictures, predator-prey, erosion, natural selection. All right. We made it through that section. So that was 22 questions on biology. And that was out of 80 in total. And that's pretty standard. So about a quarter of the test is on the biology. Yeah, for sure. I read the best way to go through those questions where you have to read something is to read what the question is asking. Keep it in mind as you go through it. That would be a great strategy, actually. So read the question first, and then go through and read the information that's kind of given, the little blurb, and then you'll be able to kind of look for what is actually being asked in the question. That's a great strategy. Yeah, for sure, Abby. And yes, Alex, there will be motion on the provincial. We'll get to that. So first 22 questions, biology, and then it says physical science. So this is the chemistry section of the test. Use your periodic table, elements, pH scale, names, formula, common ion sheet. You go through subatomic particles found in the nucleus of an atom. You mean you've done that stuff since grade 8. You should be pretty good at that by now. Lewis diagram, Bohr model stuff, Bohr model, Lewis dot structures, diatomic molecules, indicators, periodic table questions, naming covalent molecules, naming covalents, balancing. You'll notice the balancing questions, instead of asking you or showing you a fully balanced one, because then you can just count, they'll say, hey, what coefficient do I need to put in front of oxygen in order to balance this? So without giving you the answer, they're just wanting the coefficient in front of that one question. And then similar here, they're asking for a full set of coefficients. And if they give you a full set of coefficients, what you can do is you can put them in. So you go, okay, 1, 1, 1, 1, 1, and then you can count. Instead of having to actually physically balance it, you can also substitute the answers in, okay, that one didn't work, 1, 1, 2, 1, 1. And you can count. Does that one work? Maybe, no, yes. So you don't really, if you can count, you don't need to know how to balance, but if you know how to count, you probably know how to balance anyways. Pentane combines with oxygen. They're asking for a balanced equation. There's always a question like this, and this one was interesting because I did a demonstration similar to this. This is copper 2 sulfate. I use copper 2 chloride and iron filings. So they're putting iron into here, and then they end up with a bunch of copper. They're showing that the stopper's on top, so it's a closed system, so nothing's entering or exiting. You'll notice that the mass doesn't change. I've seen questions with a similar setup. They have like a beaker, and then they have some acid in here, and then they put a piece of metal, and there's little bubbles coming off it. And they say, what type of gas is being produced? It's hydrogen, usually. So it's asking the type of question, or the type of equation. You have iron filings, so that's Fe is iron. Copper 2 sulfate is going to be CuSO4 maybe, and then you get FeSO4 and Cu. And it's asking what type of equation is this. So in this case, it's a single replacement. The iron is by itself. It kicks the copper out. Now the copper is by itself, and then the iron is in the equation. So single replacement type reaction. Just a bit of a different way, showing you a picture instead of saying, hey, this happens. There'll always be at least one question like that on there. Law of conservation of mass, acid and neutralization. Number 45 was a tricky question. Number 42. Yeah, Abby. Pentane combines with oxygen, forming a gas and water. Which of the following represents a balanced equation for this reaction? So just like the math provincial, there's always two that if you knew a little bit about something, you could usually cancel out at least two of the answers. And in this case, we talked about the magic 7. Oxygen, chlorine, bromine, iodine, nitrogen. I forget what they all are. 1, 2, 3, 4, 5. I'd have to look at a periodic table. I don't have one in front of me, but these are diatomic. O2, Cl2, Br2, I2, N2. If I look at oxygen gas here for the first 2 letters, I see that it's not diatomic. So I can automatically get rid of A and B because they're not diatomic. If oxygen's by itself, it has to be diatomic. Now, it's asking us to balance. So I can count, and maybe I'll start with carbon. See 5 carbons here, 5 here. That looks good. With combustion type reactions, you're going to end up with oxygen being a problem. Oxygens, I have 5 times 2 is 10, plus another 6 is 16 oxygens. But on this side, I only have 5 oxygens, so it's not C. It has to be D. Does that answer your question, Abby? Or am I just skirting the problem? Where can we find the law of conservation of mass? It wasn't the laws of conservation of mass, there was just one law. Law of conservation of mass says matter can't be created or destroyed. Basically, if you start with 117.35 grams, you must end with 117.35 grams. If you start and end with the same amount, it follows the law of conservation of mass. If you start and end with different amounts, it doesn't. And we did talk about like nuclear reactions kind of violate the law of conservation of mass. They don't really, but they do. Anyways. So this experiment provides evidence for the law of conservation of mass. You'll notice that again, it's kind of like an English type question. You get words like supported and refuted. Supported means agree, and refuted means disagree. If you run into words that you don't understand the meaning of in your science provincial, put up your hand and ask, hey, Mrs. Ward, I don't understand what refute means. And because you're asking a question about English, not necessarily science, the person may help you. I'm not saying they will for sure. It's kind of a judgment call for them. But it's kind of weird that they have this, not complex language, but supported and refuted, kind of different things than you've probably heard before. So the statement is supported by the information. The mass doesn't change. It stays the same for both. So it's supported. All right, I'll just fly through the end of this. So 46 now. The first section had 22, so 46 minus 22, is that 24 questions on chem. So far, 22 questions on bio. So there's 80 questions, we're up to 46. So over half the exam is chem and bio. Just over half. Physical science is radioactivity, technically physics, but it kind of looked like chemistry. This is a really small section, tells you what page is your data book to look at. Alpha, beta, gamma, half-life questions. There you go, really short section. Then the next one is motion. So this is physics. I'm not going to give you guys a specific physics review. I mean, we've just covered it. What is the displacement? Please, please, please promise me you'll look at the axes of your graphs and determine if it's a velocity time graph or a position time graph. Super commonplace, students will make mistakes. Don't make it be you. It's position time, position time, position time. This one might not even have a velocity. There you go. Now it has a velocity time graph. Of course, a horizontal line on a velocity time graph means something different than a horizontal line on a position time graph. So be careful. Be careful, be careful. Nice little ant asking about the graph. Leaning Tower of Pisa, we actually talked about that in class. Galileo dropping those two mass stones off of the Leaning Tower. Superman. Cool. And then we have earth science. Abby, you had a few questions out of earth science. This is the end of this exam. So earth science, make sure you use your data booklet for your images. That's it. It says end of examination. You're done. Is there anything you wanted specific out of there, Abby? I am going to wrap my brain around the question from the learning guide. I apologize for not being able to figure out how to do it on the spot. Number 10. So I'll get back to you with this next day for sure. And again, I apologize for not having an answer for you for that. If you are able to submit, if you just do the second part, just the area calculation, that's all I'm looking for. So that's good if you can get that done. Of course, that's kind of it for Unit 9. We've gone through it. You should be able to submit that learning guide. You can bring it to me tomorrow, or you can submit it online. Hopefully you can get the Unit 9 test done by Friday. That's kind of my goal. If you can't, then just send me a message. But really, all of our stuff should be done by this Friday. Hope that can be accomplished. It seems pretty reasonable. I'm going to go through these questions with whoever wants to stick around and go through them. I know the calendar said that we'd only have class till 10:20 today, but I don't have to teach at KSS right now, so I have a few minutes. So if you want to ask questions about this exam, I'll go through them. If you want to sign out and get your day started, that's fine as well. So I'll leave anyone who wants to leave. You hopefully will see me tomorrow at KSS, about 8:45 in the front foyer, room 141. I said I'd draw a map of KSS. Here we go. KSS is a big square. Right in the middle is the gym. And these are the front doors right here. And then right in front, inside the front doors is the multi-purpose room, also called the MPR. So if you walk right in the front doors, I'll be sitting right here. Hi. If I'm not there, if you want to get to the classroom yourself or you show up a bit late or something, if you go in the front doors and you take a left, room 141 is right here. Or you can go in this door on this left side of the school and just go straight into room 141. The teacher who teaches in that room is Miss Kulak. And she was nice enough to donate her classroom for us for the day. So we'll hang out in the MPR at the front of the school until about 8:55-ish. It kind of gets busy at that time, so there'll be tons of students in there kind of milling about, maybe 8:50 or so. After that, we're going to just meander down to room 141. So if you go in the front doors, take a left, take a right, it's on down the first hallway. And KSS is super easy because it's just a big square, so you can't really get lost. If you want, you can just go in the left doors at the front, straight down that hallway, and then it's on the bottom floor, room 141. So if you want to come in with me, meet me in there. I will take you down to room 141. We can go as a group, but I'm not going to just sit there until everyone shows up. Because some of you are going to probably show up a little bit late or early or whatever. If I'm not there, you can go straight to 141 if you want, or you can hang out in the MPR. Either way, we'll get you to room 141, hopefully. And there you go. So we'll see you guys tomorrow. Abby, 69, 73, 76, and 80. Jump through these real quick. 69. So the S waves can't go through a liquid, and it says right on this diagram solid liquid, and it's just kind of one of those memorization things for 69. So hopefully there's a D somewhere in here. Yeah, letter D, D. So because S waves can't travel through a liquid, remember they showed if we had an earthquake happening right here, the P waves would go through and then they kind of get like bent a little bit. So that's a P wave. An S wave would physically get blocked. So the S waves can skirt around the edge, but they won't make it right through that liquid because that outer core. That's a good point that the upper mantle is semi-liquid. When we say semi-liquid upper mantle, think of it as like it's hard to describe how thick it is. It's almost fluid, but it's not really. Don't think of it as a liquid. Think of it as a solid that kind of moves. I don't know, that's probably a bad way to describe it, but it's not as liquid as you might think. 73. Which following tectonic mapping symbols would correctly show this plate boundary on a map? So we have this, the Indian-Australian plate is going under the Eurasian plate. And they've kind of shown it as a convergent boundary, and you can see that this plate is actually going under the other plate. So letter C is a transform boundary, so I get rid of that. Letter A is a divergent boundary, so I don't want that because these two plates are coming together. What other choices do I have? That's it. So remember, A is divergent. This is a transform. And this is convergent. Oh. Getting a bit ahead of myself. That was fun. Which of the following locations can deep focus earthquakes occur? With a transform fault, you have, I'm going to attempt to draw a three-dimensional image here. So these are my two plates. One is going that way and one is going that way. So transform fault, you have plates sliding past each other. Earthquakes don't tend to happen at deep points because they can happen, right at the surface. They don't have to happen down deep. So anything with a transform fault, because your plates are moving past each other, your earthquakes are going to be really shallow. I'm just wondering if earthquakes can occur at divergent boundaries. You'll get really minor ones, but not typically. So you can get rid of divergent. Oceanic continental and continental continental. When you have two continents coming together, think about like the Himalayas. Those are really thick plates. The deep focus earthquakes are going to happen at a convergent boundary that has a subduction zone. So with an oceanic, and then you have a big, thick continental plate. Because that plate is being subducted, you get really deep earthquakes way down in the bottom where the big continental plate, where you get that ocean plate going under it. So because it's getting subducted under it, you get really deep earthquakes because they're in contact very, very low down all the way until they start to melt. And then you get your volcanoes and stuff happening here. So no, in general terms, don't think of earthquakes happening at convergent boundaries. Or divergent boundaries, sorry. 76. Which of the following factors is responsible for the continued motion of the Explorer plate off the coast of BC? So, did I only steal that page? Okay. So I find my data booklet, here's the Explorer plate, and then I gotta figure out why is that plate moving. So you can see that there's a bit of a divergent edge, meaning that it's getting pushed kind of this direction, and then it's getting subducted there. So you have the Explorer ridge is causing this plate to kind of get pushed in this sort of direction. It's getting subducted under the big plate. So, which of the following factors are responsible for the continued motion of the Explorer plate? It's kind of tricky. I would go with slab pull and ridge push. Ridge push means that you're going to get the push on the one side, and then the slab pull happens as it gets subducted on the other end. I would go with A. Mantle convection is actually what would start the plates moving, but I don't know if it would continue them moving. I would not choose mantle convection. That picture was there. Obviously, you forgot to look. That's okay. And 76 and number 80. Last question on the test. A trench occurs. You get trenches at convergent boundaries because you have a big subduction zone happening here. You have your big continental plate. You need to start to learn how to draw these diagrams a bit better. All right, so here's my big continental plate. I have some ocean. This is where your trench is. And trenches occur at subduction zones, at convergent plate boundaries. You get, at rifts, you don't get trenches. Faults are at transform, ridges at divergent. That's perfect, yeah. All of that is completely correct. So trenches happen at convergent boundaries, usually continental oceanic plate boundaries, because you get the small oceanic plate going under, and where it meets, where the two plates meet, you get a trench forming. If you have plates moving apart, magma pushes up, you get a ridge, mid-oceanic ridge, and then transform faults just slide past each other, so you don't really get much happening at those, other than earthquakes. Hopefully that was good, Abby. We'll go through the entire test eventually, and if you run into more problems, we'll have time to go through that as well. So there you go. I'll leave you guys for now. Have a great afternoon. We'll see you guys tomorrow. Thanks for sticking around.